Hi everyone, welcome to this video on lesson 14 of atomic structure and the periodic table. This lesson is on halogens, trends in group 7. And what we're looking at in this lesson is how the trend in group 7, as you go down the group from fluorine down towards bromine and iodine, how it's the opposite trend to the one we observed in the previous lesson in the alkali metals. So, whereas for the alkali metals, as you go down the group and the atoms get larger, they get more reactive. What we want students to notice first and foremost is as you go down the group in group 7 and the atoms get larger, what actually happens is the elements get less reactive. Now, I've included a video in the slides. You may wish to demo this yourself. You probably want to do it in a fume cupboard because the halogens are not very nice gases. Or you can use the video as well. And what we really want to draw students' attention to is the difference between reactions of the larger halogens like bromine and iodine versus fluorine. My mind has gone completely blank. Yes, what we want to show to students is if we're reacting them with certain metals, commonly, and I seem to remember when I was at school, my teachers did this with iron wool. I'm not sure whether I've done it. Maybe I did many years ago as a teacher. I actually think the video that I've linked in the slides, which is reactions with aluminium, just makes that trend a bit more obvious. But again, speak to a technician. You might have they might have the expertise and the risk assessment for you to do this yourself, or you can just use the video. But I like aluminium, and that's what I'm going to talk about here. I had to decide whether I would how I would do this, whether I would start with the small atom and then move to the big atom, or I mean, in the video, it starts with bromine. In fact, I think it starts with iodine, and then goes to fluorine at the end. So I'm going to keep it in that order. You can choose whichever you prefer, but there is a potential for confusion there. It's worth stressing, as we'll do later, that even though I've started with bromine, that is the larger atom of the two that in this case I'm comparing. Anyway, the point is, bromine, when it reacts with aluminium, you get these little flames. It's kind of not mega exciting. It's not a big explosion or anything like that. So the flames are telling you there's something going on. There's some sort of reaction, which is probably exothermic, but it's not a kind of crazy one. Whereas, and I think the video shows this really nicely. As soon as you put the aluminium into this glass cylinder full of fluorine, it goes boom. And if you wanted, you could show there's a great video somewhere of Peter Wathers doing a reaction between cesium and fluorine, and it's like a mega explosion. But anyway, this one is fine as well. So the first thing you want students to notice, again, like we did before, is that is a more vigorous reaction. And it's important that they see that. Don't go straight into talking about electron shells and shielding. Start by showing them the two reactions, because what we're going to do then, as we did before, is zoom in on what's going on in each case. So what I'm going to do here is perhaps I don't want to reveal all of my diagrams. I'm going to zoom in on each case and show exactly what's going on. And this is what I've done here. And I've drawn these ahead of time just to save you a bit of time watching this. And again, what we can do is say, well, look, bromine is further down the group, so it's a bigger atom than fluorine. And essentially what's happening in both cases is the same thing. Now, again, purists might get a bit upset because it's not just one aluminium that's going to react here. It would actually be 3. I think you'd end up with AlBr3 and AlF3. I'm just going to show one just to keep it simple, because I'm not too worried about balanced equations at the moment. I really want to illustrate the point about bromine. So I'm saying essentially what's happening, the reason you're getting a reaction is because aluminium is donating an electron to each bromine or each fluorine atom. So what we can do then is zoom in on what's going on in this part. And again, I've not done kind of balanced equations like I did before, or not even balanced equations, but I've not shown the products like I did in the previous video, just because this one's a bit more complicated. But what we're really interested in is the fact that, okay, why are they different, given both of them are taking on extra electrons. So I'm going to zoom in to my final diagrams, and I'll zoom in and then I'll show these on the visualizer. So what we can see here is that firstly, bromine is a much larger atom. Now again, the chemistry purists would get upset here because bromine is bigger than one of the atoms that fits the 288 rule. Yeah, they only go up to, chlorine is the biggest group 7 element, but I thought the contrast between bromine and fluorine is more obvious. If you're a purist and you want to stick to chlorine, I think there's good reasons for doing that. I'm just going to kind of skate over it and not hope the students don't pick me up too much on that. But that's fine, that's really up to you. But what I want to show is that in this atom, again, I've got lots and lots of electrons here compared to in this fluorine atom where I've not got many. So I might emphasize here, in this case, I've got lots and lots of shielding. I'm going to say, okay, lots and lots of shielding here. That's kind of pushing that these outer electrons away. It means there's a weaker force of attraction on the outer electron. But what we need to emphasize to students is that doesn't make it more reactive, because these two elements, bromine and fluorine, are in group 7. To get themselves a full outer shell and be more stable, they need to take on one more electron. So actually, the point here is with shielding, that means it's less likely to attract that outer electron and form that negative ion that we see here. So contrast this with fluorine. So again, you can show to students, well, and I'm just showing by comparison here, let's do my arrows there, just showing by comparison that here we've got less electron shielding, and you might want to add that as a note, or depending on the group you've got, you could just leave that without telling them. I've got less electron shielding here because it's a smaller atom, and again, really emphasize that point that it's a smaller atom because it's further up the group. Less electron shielding, and therefore I've got this stronger force of attraction. Again, you might want to write a note of that, or just tell them, and you know, when they're writing later on in the lesson, that's where you really want them to remember this. And then the really important point, and again, I'm going to illustrate it like I did in the previous lesson with the thickness of the arrow, but because you've got less shielding in that atom, let me emphasize, in that atom you've got less shielding and a stronger force of attraction to that outer shell from the nucleus, there's going to be a much greater likelihood of fluorine gaining that extra electron it needs to get a full outer shell. And then, like we said before, it's really important that you said, okay, it's more likely to gain an electron. Now let's zoom back out again and go back to the concrete. That's why it's more reactive, because it's much easier for this reaction that we sketched out in simple terms here to take place. And again, in this lesson, I would show the demo or the video of the reactions happening. I'd explain why they are in terms of electron shells or energy levels and shielding, and how easily electrons are, in this case, gained. And then I'd get students to do some writing. And it's worth stressing, I didn't say this in the last video, but I'll stress it now. These are absolutely classic exam questions. And this lesson is a little bit like, we need to prepare students for exams, and we need to make sure that they are going to be able to answer that, because it's a really common one that comes up in many years. So yeah, it's worth tailoring your exposition really, really carefully to support students in writing really fluent answers, and then they're going to have the best chance of success when they do eventually get to their exams. So that's, we've done group 1 in the last lesson, we've done group 7 today. In the next video, we'll be looking at the noble gases group 0.